So now we're going to start looking at the operation of adding and subtracting rational expressions. And the most important thing to remember for these operations is that you do need a common denominator for them. And with adding and subtracting, you cannot do the cross-canceling or the canceling from adjacent fractions. So usually you want to combine everything into a single fraction first and then perform your canceling steps. So I'm going to show you with regular numbers first, and then we'll see how that applies into some of the more complicated rational expressions afterwards. So in this case, you can see that we have three different denominators, which means we cannot combine these yet. I'm going to have to find the smallest number that all three of these go into. Now in this case, all of the numbers can go into 28, so I can identify what each fraction needs to be multiplied by to equal 28. If I multiply the first fraction by 14 over 14, then on the top of the fraction, I'll have 14. And at the bottom of the fraction, I will have 28. So we're multiplying both top and bottom by 14 for the first fraction. For the next fraction, I don't need to do anything there actually, because it already has the correct denominator. So I'm just going to leave it as 1 over 28. And then for this last fraction, I need to double both the top and the bottom, and that'll turn the 14 into a 28. So for the last fraction, I was multiplying top and bottom by 2. And that's on top and bottom. I'm not just multiplying by 2 over 1, I'm multiplying by 2 over 2. So now that you have a common denominator, when you're performing the operation of adding and subtracting, the denominator stays the same actually. So my bottom is just going to be a 28 regardless. Don't actually add or subtract anything in the denominator. Only perform the operation on top. So 14 plus 1 is 15, and then subtract 2 away to get 13. And then usually you would see if there's anything that can be simplified out of your final answer there. But in this case, there are no common factors between 13 and 28. So now we're going to apply that same concept you just saw, but this time we're going to be using it with rational expressions. So now we have some factoring and some multiplying with variables to deal with. So the first step is going to be to do any of the factoring that you can in the denominators. So my first fraction, I'm going to have an x on top, but I recognize this denominator as the difference of squares. So I'm going to break that down as x plus 9 and x minus 9. Now I'm going to look at the second fraction. So it's plus, I have a 9 on top, I'm not doing anything up there. But I need to factor the bottom again. So this time I'm looking for two numbers that multiply together to equal positive 81, but add together to equal negative 18. So that would be x minus 9 and x minus 9, negative 9 times negative 9, and adding them together. Instead of writing x minus 9 twice, I'm just going to write x minus 9 squared. And then for the last fraction, we have nothing to factor. It's just x plus 9 down there. So this is usually the part that gives people the most trouble. I'm going to look for the smallest thing that all of my denominators can go into. Now, this first fraction has an x plus 9 and an x minus 9. The next one has two x minus 9s, and the last one just has an x plus 9. So you're looking for the smallest thing you would have to multiply each fraction by to make them all have the exact same thing in the denominators. Well, since I know I need an x plus 9 everywhere, that means the other fraction right here is going to have an x plus 9 multiplied by it. So I'm going to change colors here to make it easier to see what I'm multiplying in. So the middle fraction definitely needs an x plus 9 to make it match. Now this fraction had two x minus 9s. This one only had one, so I'm going to need an x minus 9 on this fraction. And then for the last spot, this one only had an x plus 9, which means I need two x minus 9s being multiplied in. So now if I looked through what my products would end up being, this one would have an x plus 9 and two x minus 9s. This would have one x plus 9 and two x minus 9s. And this one would have an x plus 9 and two x minus 9s. So I've found the smallest thing that they have in common, the least common multiple. And now I'm going to be able to actually multiply those fractions on the top and the bottom so that I can get the correct common denominator. So for the first fraction, remember you're multiplying this on top and bottom. So on top, I'm going to have x times x minus 9. So this will be my first numerator. For the second numerator, what I have on top was a 9. And I'm multiplying this one by an x plus 9. And then my last one, be careful, this is a minus sign. My last numerator was a 1, and it's being multiplied by x minus 9 squared. Now I'm just writing all of these as a single fraction, because at this point we already identified that we're going to have a common denominator. So now I know that I have all of that stuff over my x minus 9 squared and my x plus 9. That was our least common multiple that we got in all denominators. And just like I showed you guys with the regular numbers, you don't actually do anything in the bottom. So that is my denominator. It's the 3 parts, the x plus 9 and the x minus 9 squared. So all I have to do is some simplifying and combining terms, distributing, whatever the case may be, in the numerator up here. So I'm just going to focus on that really. So from the first fraction, x times x, and then x times negative 9. Next one, also distributing, so 9 times x. And you may want to use parentheses so that you don't make a sign mistake somewhere. I'll show you the last part where the distributing is really going to matter. This one's a plus, so it doesn't matter too much. And then 9 times 9 is 81. And then for this last one, like I said, if you use parentheses, we'll better remember that we need to distribute the negative sign through in a second. But right now, I'm actually just evaluating x minus 9 squared. Multiplying by 1 won't change anything. So x minus 9 squared, you might want to actually write out x minus 9 times x minus 9 to make sure you do this correctly. So it's x squared minus 18x plus 81. And again, I'm just going to ignore the denominator for a second. So on top, if I actually go through and start combining like terms, don't forget to distribute the negative all the way through. This would now be x squared minus 9x plus 9x plus 81. And then it's going to become a negative x squared. Distributing the negative gives me a positive 18x. And then a negative 81. So you can see that a lot of things are actually going to cancel out here. So I'm going to change colors to show this. You can see that I have a negative x squared and a positive x squared. So those are gone. I have a negative 9x and a positive 9x. So those are gone. And then I have a positive 81 and a negative 81. So a lot of things actually disappeared in this case, which means after doing all of that combining like terms, all we're left with on top is an 18x. And then our denominator that we already discussed, that's the x plus 9 and x minus 9 squared. The order of writing those two things does not matter because multiplication is commutative. 2 times 3 is the same as 3 times 2. So whichever order you write those things in should be fine. So they want our answer in factored form. That's what the directions specify, which is why I'm not going to actually multiply out this x plus 9, x minus 9 squared. And that's actually fairly common for when you're working with fractions. And that is it for the review. It is a little bit tricky. You have to be careful about what you need to multiply each fraction by to get a common denominator. Worst case scenario, you can always just multiply all of the fractions by all of the denominators. It might add some extra work for you, but if you can't figure out what the smallest thing is that they all go into, just multiply every single fraction by all of the denominators combined, and that'll cancel out a lot of things, and you'll just have more computation to do here. Once you've done that step, it's just a matter of you going through and distributing and combining like terms, identifying which things cancel out, and then again, do not do any of the expanding the denominator. So that's actually less work. We don't want you to multiply that out. We want you to leave those things in the factored form. So that's it for the review. Thank you guys.